Egypt is building Africa's first high-speed rail network. A fully electric system spanning 2,000 kilometers connecting 60 cities at speeds of up to 250 kilometers per hour. And it's costing over $23 billion. That's not just a new railway, that's a new spine for an entire country. Some are calling it the Rail Suez Canal, a modern infrastructure corridor that could reshape how Egypt moves people, goods, and opportunity. But how do you build something like this from scratch, across deserts, mountains, and decades of outdated systems? Let's take a closer look at how Egypt is pulling off one of the most ambitious infrastructure projects in African history, and why it matters far beyond just Egypt. Egypt is a country of over 110 million people, and it's growing fast. Over 60% of the population is under 30. This is a young country with rising energy, rising demand, and massive transportation problems. Buses are overcrowded, roads are dangerous. The existing train network is slow and decades out of date. For a country aiming to become one of the world's top 30 economies by 2030, that's a major problem. So in 2021, Egypt launched a bold plan. A nationwide high-speed rail network that could change how people and goods move across the country, and eventually the continent. The project is being built by a partnership between Siemens Mobility, Orascom Construction, and the Arab contractors. Their goal, a fully electric triple-line rail network stretching 2,000 kilometers from the Red Sea to the Mediterranean, and from Cairo all the way to the Sudanese border. It's not just about fast trains. It's about regional development. These lines are designed to support passenger travel and freight, while opening up new corridors for housing, agriculture, industry, and trade. In short, it's about more than mobility. It's about building a new economic backbone for Egypt. Line 1, the Green Line. The first of the 3 lines is called the Green Line. This route connects Ain Sokhna on the Red Sea with Marsa Matruh on the Mediterranean. Along the way, it passes through Egypt's new administrative capital, Giza, and Alexandria, creating a high-speed corridor that links the country's 2 coasts. At 660 kilometers long, with 21 planned stations, the Green Line is expected to carry 30 million passengers per year. That's equivalent to nearly a third of Egypt's population riding the line annually. And by connecting the new capital with key ports and cities, it also supports Egypt's ongoing urban expansion strategy. Line 2 is the Blue Line, a north-south axis that runs from Giza to Abu Simbel, near the Sudanese border. This is where things get even more ambitious. Egypt plans to extend the Blue Line further south, connecting to Toshka and Wadi Halfa in Sudan. This would create a direct rail corridor between Cairo and Sudan, a huge step towards stronger trade and mobility between North and Sub-Saharan Africa. If completed, this could become a major artery for cross-border economic integration. Finally, there's the Red Line. This line runs east-west between Luxor and the Red Sea ports of Safaga and Hurghada. The goal here is threefold. Support tourism in the Red Sea region, improve agricultural transport from Upper Egypt, and boost freight capacity between inland production zones and export terminals. Together, these 3 lines don't just form a network, they form a national strategy. Building high-speed rail in Europe or Japan is one thing. Building it across Egypt's terrain is something else entirely. The project has required excavation of over 11 million cubic meters of soil, enough to fill 4,000 Olympic swimming pools. Rail beds are being stabilized with volcanic basalt, which resists heat expansion and keeps tracks stable in the scorching sun. Much of the track runs through desert, where temperatures can reach 50 degrees Celsius. So Siemens is using corrosion-resistant metals and sandstorm-sealed components. The network is powered by a chain of substations, transformers, and overhead catenary systems designed to survive Egypt's climate and deliver consistent power across vast distances. This is extreme engineering, done at scale. To run this network, Egypt is building a diverse, high-performance train fleet, For high-speed travel, they're using the Velaro train, a 250 kilometers per hour bullet train adapted for Egypt's climate. It's sealed against dust and sand with climate-controlled cabins and advanced safety systems. Each Velaro can carry up to 481 passengers. For regional routes, Siemens is supplying DeZero trains, designed for shorter intercity trips. And for freight, the network will rely on Vectron locomotives, heavy-duty electric engines built to haul cargo efficiently across long distances. Egypt has already ordered 94 DeZero trains, dozens of Velaros, and an expanding fleet of freight engines. Behind the scenes, this rail network will be one of the most digitally advanced in the world. Egypt is deploying ETCS Level 2 signaling, a European standard that allows for high-speed, high-density, real-time train control. It increases safety and allows trains to run closer together without collisions. All of this is monitored from control centers like the one in New Capital Station, where operators can track every train in the system. And thanks to Siemens's Railagent X platform, Egypt will use AI-based predictive maintenance, identifying problems before they cause delays. The stations aren't just stops, they're anchors for growth. Major nodes like Giza, October Gardens, and 6th of October City are being built as smart hubs, with parking, retail, smart ticketing, and links to other transport systems. By integrating rail with urban planning, these stations are designed to become new centers of activity, supporting population growth, housing development, and commercial hubs. This isn't just infrastructure, it's city building. Let's step back and look at the scale. This project will eventually connect 60 cities with more than 60 stations across Egypt. It's already estimated to create over 500,000 jobs, not just in construction, but in operations, logistics, engineering, and services. It also links directly to ports, airports, and industrial zones, forming a multimodal network that can reduce Egypt's dependency on road freight and lower transportation costs nationwide. Electrifying transport isn't just smart, it's necessary. This system is expected to reduce CO2 emissions by 70% compared to driving or flying the same distances. That's a major win for a country vulnerable to climate change. And Egypt's ambitions don't stop at its borders. Planners are already exploring future links to Libya and Sudan, creating a continental rail hub centered around Cairo. Egypt isn't just building a national rail system. It's positioning itself as a gateway between Africa, the Middle East, and Europe. Still, the project isn't without criticism. Some question the cost. $23 billion is a massive investment for a country still dealing with poverty and inflation. Others worry about accessibility, especially for rural communities that might be bypassed. There are also environmental and archaeological concerns. Egypt's landscape is rich with history, and high-speed rail construction doesn't always play nicely with ancient sites. To address these, the government has promised long-term public-private partnerships, international oversight, and mechanisms for local accountability. But the questions remain. Egypt is taking a bold leap, building Africa's first high-speed rail network at a scale and speed that few expected. If it works, it won't just transform Egypt. It could set the stage for a new era of African infrastructure, where rail replaces roads, where smart systems replace chaos, and where the continent moves faster and cleaner than ever before. What do you think? Can Egypt pull this off? Drop your thoughts in the comments. Don't forget to like, subscribe, and hit the bell so you don't miss what's next.